Yes, now after creating the tools, we need to go and create a program on ShopTurn. I want to use a contour so we can see how we can create this program, simple programs on this contour. So let's go. Once we finish this one, we go to external programming. Okay, so I want to show you the best ways of doing this. So let's go to now program, go to program manager, and then click on the new. Ensure this use test 3, then click OK. When it comes on, we have our diameter of 48, so I'm going to use 50. So okay, with the facing of 0.1 amount to face, then safety, the total length for the stock is 150. Cutting almost to, let me put minus 105. This can be minus 160. Then incremental by 2. Here you pick machine, then click on teach. It's down cut, then accept. Once you accept the header, we have put the stock of this. Then we go to turning, then stock removal. Then we change to face. Need to change to face here. Then we are doing both of it for facing. I'm using this one for facing. Diameter is 50. I can put, they say 60, for example. If I put 60, then here I want to put 0.5 or 0.4. Okay, then there's no finishing allowance for U and for X and Z. Accept. But remember the tool here, I need to pick the right tool. For example, click on the select the tool, so you can pick the tool you want. For example, there's a tool we had created. You can come here and then we put DNMG, this one, or D. You can say this one. Then you say okay. That is for roughing. Okay, then we accept. Then on the header also I need to change, because I've changed here to be 60, so I need to make sure that it's also 60. Input, then accept. Then from there we go to contour. Now we put the contour. Click on the contour, then click on new contour. You can put it contour 2 or contour or any contour, for example contour 2, yes. Then accept. Here we are starting, I'm just putting a step turning. So here we are starting at diameter 20 with a chamfer of 1. So here the chamfer is 1. So come here, put the chamfer mount and put 1. Input, accept. Then from there we go horizontal, put Z minus 25. Then put the chamfer mount, transition, or see here, sorry, put affiliate amount, transition. So you can put affiliate of 1, and then input. Okay, then from there we go to vertical. We put our X as 26, diameter 26. Input. It has a transition of chamfer of 1. Chamfer of 1. Input. Then accept. From there we go to horizontal. Horizontal. So this one, if it is horizontal, we go to minus 45. Input. This 45, it has a transition of radius 1. So you put radius 1. Input. Accept. Then after we go to 45, we go up vertical. Then from this vertical we put our diameter 32 for vertical. Input. Then this, it has also a transition of chamfer for 32 of 1. Input. Accept. Then from this we go to horizontal. Horizontal of Z minus 70, for example, Z minus 70. Input. It has a transition of fillet radius of 1. Again, input. Accept. So we are on minus 70. Then from there we go to minus 90. So we'll go to vertical first of all. Vertical. Our X is 40. Put here chamfer mount, chamfer of 1. Accept. Okay. Then from this 40 we go to horizontal. Z. From this 40 we go to Z minus 90. Minus 90. I want to put all of it, but remember it is too long. I want to put all of it. Then it has a fillet of 1. Input. Accept. Then from there vertical again, go to X 48. it has a chamfer of 1, input, accept, then I go to horizontal. Now the last one, which is Z minus 100, okay, here there's no chamfer. Okay, I can also put a chamfer. Let me put a chamfer of 1, which I'll do on the parting. Okay, then accept, then go down for safety. I said using the meta 60, input, then accept. So this is the contour that the software, the software or the controller SINUMERIK 828 will help us to create. So this is the contour. Once we finish the contour, we can either close this or we could leave it open, but leave it open, then click close. Then from here, go to now stock removal, put complete, then select the tool for roughing. I want to put this tool for roughing. This tool, let me put this tool for roughing, select, and then come to here, roughing. I want to assume to leave this by default. Diameter is 60 here, change to 60. Then the, here I can leave by default. Okay, so here we are looking at roughing. First of all, there's no undercut, it doesn't have undercut. Then accept. Again, come on edit, click on copy, then paste, click on this icon, change the here the contour to finish, then change the tool here to finishing tool, second one, select OK, then accept. Once you accept, now we go to the parting off, because this one doesn't have another part. We go to parting off, go to turning, the cutoff, select the tool for cutoff, the one we made in the part 1. Then come here on the diameter we are parting off. Which diameter are we parting off? Is on diameter 48, and then it is at minus 100. Okay, and then it has a chamfer of 1. Okay, after they say 40, if it starts reducing, goes to minus 1, then accept. Once we finish this one, now we can able to do a simulation. We see how it will behave. Click on this, simulate. Ensure that to run this one, the almost the fit rate is 100 and the speed is at 100, for example, for simulation. Then click on simulate. Once you click on simulate, in case you want to see the full speed for simulation, click on this one. Then click override 100%, so that you can run automatically. Then you can change to either side view or 3D view. So you have 3D view, you have side view, further views. You can click on override, come to further views, click on the half section, then click on this, run again simulation to see how it cuts. So this is how to program using SINUMERIK 828 on ShopTurn programming. As you can see what it's doing. This is what it's doing, and then I'll show you. This one is too close. It is too close to spindles. How do you rectify this program? So let's go to the first part. Or we say minus 60. We can say minus 170 for the purpose of ensuring that it's safe. Then we accept. From there, we can now do simulation. You'll see the jaws moves further away from the contour. You see it gives now an allowance from the contour. Or we can even change. For example, we can change our can click here, edit. Again, we change this one to be minus. For example, we can put minus 110, accept. Okay, and then do a simulation. You will see how it behaves when it's doing update on the parameters we have changed. So that now you see this, now the chuck or the jaws has moved further away from the work, so that you prevent it from knocking in case your machine doesn't have the safety feature or collision detection. Now you see this is what we have done. A simple program I have just made for a step turning, which you see at the end of it, the tool for cutoff has put a chamfer, and every place there's a small fillet to ensure that the part that is cutting is safe from the clashing. This is what you do. Once you finish, in case you see the program is okay, you can now click here, execute the program. Then here, run cycle start. Ensure that all of it is almost close to 10% or 20% for spindle speed and fit rate. First of all, if you see the first cut is okay, you can now increase this one to 100%. You can now increase this one to 100%. And you see even is cutting. Okay, another tip I want to show you. Let me reset this one first of all before we run this program. Let me click on the program. when you are starting, don't click here, because once you click here, the Siemens controller will automatically run from whatever the point it is. So in case you want to run the whole program, click on the header where the block 1, or you can renumber. For example, you can here say renumber, then 10 like this, okay. Then click on the first header, then click on simulation, so, to check if the program is okay first of all before you proceed. So this is a safety feature that is put on the advanced machines for programming, so that you're able to check that whatever you're doing is safe and able to do what's supposed to be done. Then once you finish this, you can now click now execute, or click on the program, edit program, the header on the part, then execute the program. Then from here, click, it automatically changes to auto mode, then click cycle start. When you click cycle start, it will start the program. But remember, I said there's instruction unknown in which is manually. What do you do? Because already you check it's telling you the block 1, that is block N1. So you can do reset, then you check your program. So that's why you do a simulation, so that you're able to check the program if the program is okay, so that you do what is supposed to be done when you are programming. So this is the best way you can be checking your machine. You can come here to machine work, then teach, so that you get the actual value from here. Then from there, you can now proceed to check if all the parameters are okay. You can do again simulation to check if it is okay or not, so that when you start cutting, it will be okay on your part. Remember, this one also is telling you the contour, tool change, tip, retraction error, simply because I've teached here, I've put here teach pendant, or sorry, teach TC, which is closer to the machine. So what do I do? For example, I can come to this machine mode, then jog mode, I can click on Z, then I can try as much as possible to move Z away. But remember, this one I cannot control from this side, because I don't have this parameter. Or I can say now home my machine. Let me home machine first of all, home machine for X. But remember, Siemens doesn't home the machine, and this value is not good. It's not good simply because this is a virtual simulator, and then this is a virtual simulator. The machine is not good, so don't say that your machine can go to this. And there's have a machine which is bigger than this one. So I'm using just a simulator to guide you on how to program this. So let's check our program. The program is okay, but remember, when you're running it, the areas that will be giving you errors. So what you do, always you check the program that the program is okay before you proceed. Like on this one, it's telling you 60, okay. Check here, it's okay. Check here, it's okay. Absolute, incremental. So here is where the problem is. So you can click on the machine, then click on teach. At least go far away. I'm not saying that this is the best way to do that, but and this is the actual machine. This is not the actual machine. This is just a simulator. Accept. Check that all the parameters you have put are okay. This is for roughing. Program is okay. Go to the contour. Contour is okay. Go to roughing. Roughing here. We are using the same tool. Okay. Go to finishing. We need to pick two finishing tools. Okay. Accept. Go to cutoff. The cutoff tool is okay. So in case they're not okay, you change the tool for cutoff. Then you do now your simulation. The simulation must give you the actual values when you are running a machine. This is how you check, so that you ensure that the program is okay. So this is how you check to ensure the program is okay. You can say overwrite 100% back. Okay. Then from there, once you confirm the program is okay, you do what? Yes, you can now execute the program. Once you see it's okay, then you run cycle start, the program will run. This one is only that it's telling you the point where the machine is. So the starting point is not taking place because we have not done the setup. So before you now run here, because this is just a simulator, before you run, ensure that the setup is okay on all the tools. The setup is okay on all the tools. Or let me put a symbol where I can select the tool. Let me put tool name here, and then select the tool. I want to put this tool, this one, okay, and then here cycle start, okay, and then also I want to put G54 here, G54, this one. So I like offset G54, then click cycle start to ensure that it's okay here. From there now you can initiate. For example, I can say let me put 2000 just for the sake of initializing. Input clockwise direction, for example clockwise direction, input, then cycle start, so that it activates here on the spindle, or which spindle am I going to use. So I don't have spindle S3, I have spindle S1. So from there I'm able to kind of check the parameters okay. Then if the program is okay now, once you have done your setup, you see where it is, you're able to now to run your program. You can say now execute. Even if you press now auto and then you press cycle start, the program will now start cutting at that point. So this is how you create a program, and then from there you do a setup. From there you now run and cut your part. So this is the program for ShopTurn. This is a ShopTurn program that we have made. In case you need more, to understand more, you can call us or follow us on your YouTube channel, then or comment on YouTube channel, then we'll reply to you where we are located, then we'll guide you on how to do it.